go backwards here. So yesterday, we finished this, didn't we? In our notes? Or did we skip this? I forget.
We didn't get the maximum.
Okay, we only did that bottom. Thank you. That's all I needed to know. Okay, so as we start here, just picking up where we left off yesterday. So this is lesson 4.12, just finishing it up, okay? So it says, without graphing, answer the following questions about this graph. So I'm not asking us to get the graph and draw the y-axis and the x-axis. Now, we did get the angular frequency. That was a review, kind of like vocabulary review. And just to kind of back up, we said angular frequency is the coefficient with x. Well, in this case, it's 4. And remember, angular frequency says that means we're going to cram 4 full sine graphs in the original interval 0 to 2 pi. So it's going to be really kind of skinny and smushed together, okay? But then, and I know I wrote the answers down, we just didn't talk about them. That's now I'm remembering. So we want to talk about the max and the min, right? How high does the graph get? How low does the graph get? Now, and I think I made this so that folks at home can see, these are our 3 parent graphs. So if we're talking about a sine function, here's our sine graph. The highest the graph ever gets is 1 up from the midline. The lowest it ever gets is 1 down from the midline. Where's my midline on this function? Sean, what do you think? Where will my midline go? 100. Now, I'm not drawing the graph. I'm just drawing the y-axis. So the midline is going to go up to 100. From the midline, Andrew, how high am I going to go? Or how am I going to tell? Like, remember we said from the midline we're going to go up 1 or we're going to go down 1? 20. Our amplitude tells us how far up to go and how far down to go. So from the midline, I'm going to go up 20 to get to 120. Or from the midline, I'm going to go down 20, which would be 80. And that's it, right? A sine or a cosine graph just are going to oscillate. They're just going to bounce back and forth between those two numbers. So the highest this graph will ever get is 120. It's the midline or the vertical shift plus the amplitude. And then the minimum will be the midline minus the amplitude. I didn't need to graph the function to answer that. I could have just as easily asked a different question. And I could have said, what's the range? I could have said, without graphing, find the range. Same idea, right? Once you know the max or the min, you essentially know the range, don't you? Okay, good. So we just wanted to finish that up. So yesterday, the big takeaway was changing the period of sine and cosine. We just didn't get to talk about tangent yet, okay? And so that's what we're going to finish up with. For the parent graph of tangent, when we talked about this graph on Friday, yeah, we said the period length is not 2 pi, it was only 1 pi, right? It was half as long. Now, when we draw it, we don't draw it from 0 to pi. We could, but then we'd have this, you know, two small pieces, and we could. I kind of like seeing one complete graph. So we said draw half of the graph on the left, the other half on the right. So it goes pi over 2 to the right, pi over 2 to the left for a total of 1 pi. Okay. So the period length of the tangent graph is 1 pi, which means if we want to change the period length, we're not going to do 2 pi divided by b. We're just going to do 1 pi divided by b. So just like yesterday, let's box that in, let's highlight it, let's make that stand out. Because the tangent has a different period length, we need a slightly different formula. Okay. So without graphing, it just says find the period length. It's just like what we were doing yesterday. It's just we have to pay attention to the function. So this is y equals the tangent of 3x and then plus 7. Remember, my b, it's still the same b as it was yesterday. It's still that horizontal stretch factor that's inside with the x. So my period is just pi divided by, pi divided by 3. That's the length of this graph. And I'm not graphing right now, but I just want to point out, if the length of the graph is pi over 3, how we graph, we said half of it's going to go on the right, half of it's going to go on the left. Okay, we'll come back to that, just kind of thinking about that. Sean, what's my value for B on this second function f of x?
Would be pi over 7.
Yeah, B is pi over 7. So my period is pi divided by B, which is pi over 7. Very similar arithmetic to what we were doing yesterday. How do we divide by pi over 7, Mohammed?
Multiply, you switch it.
That's right, we're going to switch and multiply. Flip and multiply, same thing, right? Which is great, because then the pi's go away, which means my period length is 7. So yesterday we were graphing sine and cosine, then we'd set up our x-axis to go from 0 to 7. But if it's a tangent graph, half of it's going to go on the right and half of it's going to go on the left. Which means we're going to graph from where to where, Skylar? I'm not asking a great question. I'm not asking us to graph here. I'm just kind of thinking ahead. If my period is 7 and a tangent graph still gets divided into those 5 tick marks, we said half of it goes on the right and half of it goes on the left. What's half of 7? Say it again. 3.5, which means 3.5 on the right, negative 3.5 on the left. We center that 0 so that we can draw one nice smooth tangent graph. I thought it'd be nice to do it with an integer instead of like a pi value. Okay? So that's the biggest difference when we go to graph tangent is we find the period, but then we put half of the period on the right and half of it on the left. This is still a length of 7, right? It's just we split it on either side of 0. Okay. All right, so let's do some graphing here. It says graph at least one period, just like yesterday. Well, I gave us 5 tick marks, so we're probably going to graph exactly one period. It says draw in the y-axis. Yesterday we gave you the y-axis because we knew where it was going to be. Well, with tangent, it's going to go in the middle, so we'll draw that in here in just a minute, or you can draw it now. And clearly label the scale on each axis. All right, so here we go. We've got y equals 3 tangent of x divided by 2 minus 3. Andrew, tell me one change that's going to happen here. It doesn't matter which one we do first.
It'll go down 3.
It's going to go down 3. We can even say the midline is at negative 3. Same thing. So can you tell me what another change that we're going to make?
The 3 on the outside.
The 3 on the outside, what's that going to do for us? Which way?
This one.
Remember, so we're close. This way is a horizontal change, isn't it?
Okay.
I need to step into the camera so they can
Vertical
see.
change.
It's a vertical change, right? Horizontal changes occur in with the x. The x is a horizontal quantity, isn't it? If this is on the outside, it's going to change the y. This is a vertical stretch. I know with sine and cosine we use the word amplitude. Technically, tangent doesn't have an amplitude. If you use that word, I'm not going to hold it against you, but I'm going to write vertical stretch. All right. What else is going to change? Mohammed, what haven't we touched yet? The period length, right? So inside it says x divided by 2. You're right, it's going to change the period length. How are we going to calculate that?
Multiply by.
Say it one more time. I couldn't hear what the last.
Multiply by 5.
So we're not going to multiply by pi. So we can look at this 2 different ways. We had a formula to calculate the period, right? It's pi divided by b. So we could look at it that way. Or we can say if it says x divided by 2, what are we going to do to all of our x's? If it says divide by 2, what's the rule? We do the opposite. What's the opposite of dividing by 2? Multiplying by 2. So if the period was pi, now it'll be 2 pi. And so some of you, the only reason I say it that way is because that's kind of how Mohammed started saying it. We have a formula that says pi divided by b. What is b in there? Not 2. Remember, b is the number that x is being multiplied by. 1/2. Yesterday, we talked about this case. We said, what if it says x divided by 2? Well, that's the same as 1/2 times x. So my period is pi divided by 1/2, which is the same as pi times 2. So I looked at it 2 different ways, and there's nothing wrong with looking at it a different way. So we have a formula to calculate the period, or we can say, well, if the period was pi, but then we're going to be doubling all of our x's, well, that's going to double the period. So the period is now 2 pi. And with a sine or cosine graph, we would go from 0 to 2 pi, but this is a tangent graph, and so we said 0 goes in the middle. So half of the period goes on the right, and the other half goes on the left. What's half of 2 pi? 1 pi. So we're going to go pi units to the right and pi units to the left. So this particular graph will sit between negative pi and pi. Let's finish the tick marks here. What's halfway between 0 and pi? Pi over 2, or 1/2 pi, same thing. Half of pi is pi over 2, which means the other side, if this is symmetric at x equals 0, it's just negative pi over 2. If you haven't already, go ahead and draw in your y-axis, right? It's at 0, isn't it? All right, so let's go back. We said the midline, we're going to go down 3. So 1, 2, 3. There's my new midline. I'm going to draw it in orange, something light. And remember, a tangent graph typically goes negative 1, 0, 1. But we're not at 1 and negative 1. We said our vertical stretch is 3. So from the midline, we're going to go up 3, or we're going to go down 3, aren't we? That's our vertical stretch, was 3. All right, I think we're ready to draw in everything. Remember, the tangent graph has asymptotes at the first and the last tick marks. When I draw in the midline, I don't want us to think it's a horizontal asymptote. That might be my fault there. And then a tangent graph goes, paragraph negative 1, 0, 1, except ours isn't negative 1. We're going to go negative 3, 0, 3, right? We stretched those extra points up and down instead of going up 1 and down 1. We went up 3 and down 3, kind of like we would do with amplitude. So from the midline, I'm going to go up 3. From the midline, I'm going to go down 3. I kind of missed my mark there, didn't I? A little off when you draw a graph so big, you know. So again, from that, I say 0, it's on the midline. It looks kind of like the right half of a parabola. And then on the other side, it looks like the left half of an opening down parabola. Wild, huh? So just like with sine and cosine, I like getting my midline, and then I kind of like thinking how much is it going to stretch up and how much is it going to stretch down, just like we would with amplitude. Okay? Good? So that finishes our notes, doesn't it? Do we have any slides left, or was that it? That was it. Do we have a back on anything? I'm just kind of, no, probably not on this because we didn't have a cover page. So I just added a few extra things that we could do. Just a couple. If you have scrap paper and you want to use it, fantastic. Okay, but I would just like to kind of tack onto this. I just have to remind myself. Let's try this one on your own. Okay, so let's take, if you scrap paper, if you need scrap paper, I have hundreds of pieces, so I can certainly come around with some. I'll make this a little bit bigger so we can see it from the back there. But let's take a few moments and start this one on our own. For those of you at home, hopefully you can see it. If you can't, let me know. We're just going to grab another tangent function. Does anyone need a piece of paper? Yeah, sure. You're welcome. Paper, you're all set. That's fine. Anyone else want some paper? and I guess I should have referenced that. I used a theta here instead of x. Could use any variable, right? T, theta, x. Don't let that bother you. Treat it just like your x, okay? I put my finished graph up on the board. I don't want you to look at it until you're done, right? But I also wrote the coordinates on those extra points just so you can tell where they are, because it's hard to see. My graph is so big. So I would think that as stuff, right? How'd you do? Did okay? Good. Good. Looks good. Didn't draw a graph. I'm just kidding. Like I asked you to draw a graph. No, I'm kidding. I know, that's the easiest part, right? Yeah. How are we doing? Good? Okay. Okay, good. For those of you that are done, I'm just going to ask you to think about this. What would change, if anything, if that 11/2 was negative? So if you're done, I just want you to ask yourself, what would change about your graph, if anything, if that was a negative 11/2? Okay? If you went ahead and kind of draw it in on your paper, that's up to you. So you can start drawing graphs bigger than the, top half of your body. They get a little out of control, don't they? So, mine aren't so great. What I'm hoping that we take away from that question is that when you throw a negative in front of any graph, it flips it over the x-axis, right? So my original graph was in blue, And if there was a negative in front, we just flip everything over and that graph would go downhill instead of uphill. That's all. Just a nice little reminder about transformations, okay? Okay, if you're still working on this, that's okay. But for those of you that are done, I'm gonna put one more question up on the board. It's not something you need to write down, just something I want you to look at. And I'll come around and I'll kind of see where we are there. And then when you're done, finish up worksheet 12, okay? So I'm gonna put one more question up here. It's hard to see, I get it. Do the best you can. It says it's multiple choice. Well, be careful I say that, but which of the following graphs have the same angular frequency? So which of these 4 graphs, and they're Roman numeral 1, 2, 3, and 4, which ones of these graphs, this is not in your notes, but just kind of take a look at the board if you can see, which of these graphs have the same angular frequency? And you and I can talk about it as I walk around, and once you're done with this, then let's finish worksheet number 12, the few graphs, 3 or 4 that we skipped that were about tangent. Okay, so I'll kind of slide out of the way here. How do we do with this? Looks good. Everything went okay? How do we finish up? Excellent. Good, okay.
Just make sure you get this out, so that you realize that this graph is gonna eventually get real steep. Yes, tangent graph has a lot of aspects.